Basically, what I'm here to talk about today is sort of the basics of dimming LED bulbs and solid-state lighting fixtures. Controlling LEDs is what we're here to talk about today. Okay, so taking a look at it, what I'm going to focus on is a little bit more of the implementation aspects of it, as opposed to the technologies itself. It seems like I think we've covered that pretty well between the dimming curves and things like that. I will touch on how those curves, those technologies of the LED itself, how either the dimming technology, how it's being utilized in order to address that. So we're going to be talking about a little bit of the driving forces for controls of LEDs, the challenges in controlling screw-in LEDs and what the wall box solutions are. So this is really where those dimming curves and some of those dead travel comes into play. Looking at commercial fixture LED options. So a lot of what we're talking about sort of affects the screw-in bulbs, which is obviously both residential and commercial. But then also there's a tremendous move into replacing your linear fluorescent fixtures with LEDs. So we're going to talk a little bit about that and some of the challenges there and some of the solutions on the commercial LED side. So first off, if we take a look at, all right, we're putting in LEDs. Why? Well, this is AEE. What are we about? Saving energy. What do LEDs do? Save energy, right? We took a look at the efficacy, the lumens per watt, how much more light that you can get out with a lower wattage, right? So controls, well, that's redundant, right? Why are we putting controls on? You're already getting our savings with the LEDs. Okay. Well, there's a couple of things that go into play there. We are going to get we're going to get additional savings with dimming. All right. John showed the dimming curve where basically every 10% that you reduce the light output, you reduce your energy by 10%. Then you add in the perceived light level where if you want to have 50% perceived light, you're actually 32% output. Okay? It's been a while since I've done my engineering, but I think that's about 68% savings, right? So it's a dual strategy. So you reduce your connected load with the LED, and then you reduce that even further with the dimming control. Okay, so there's a energy reason to do it, right? Well, there's also another reason to do it, and it's called the National Electric Code. Okay, so if we take a look at what we have up on the screen, it's a little bit small to see, but pulled two sections out of ASHRAE. So the National Electric Code references ASHRAE. So looking at the two things that I took a look at that really apply to dimming and apply to dimming control, multi-level lighting control, and then daylight responsive control. Now you can do multi-level by switching lamps on and off, right? But if you take a look at the implementation cost and with the technology, especially where LEDs, where it's primarily dimming as a standard, it makes a lot more sense from an installation point to be able to use dimming to accomplish these. So taking a look back at 2007, so ASHRAE 90.1 2007, there wasn't any reference to a requirement for multi-level control or for daylight responsive control. Daylight responsive control being you have a window over there, you have sunlight coming in, so instead of just blasting your light trying to overpower the sun, reduce your light, allow the levels to be where they should be, and at that reduction you get energy savings. So taking a look in 2010, that's where we had the first instance of these requirements coming in, saying that you have at least one control step between 30 and 70%. Okay, in addition to on and off, and then also on the daylight control that you have one daylight zone parallel to the window. Okay, so that's driving you into controls in order to meet these requirements. 2013, same thing on the control steps, but then also throwing in that continuous dimming obviously meets that requirement as well, and then adding in the second daylight zone for daylight harvesting, and then having more levels required for your daylight responsive control as well. Okay? And then the last piece of it, 2016, the most recent, again, where you're getting the multi-level lighting control requirements, and then same thing on the daylight responsive, so that the requirements are staying in. And then anyone that's on the government side of things, GSA references this, the DoD references this, all of the major design guides on the government side reference ASHRAE, and then they specifically call out some of these requirements as well. So this is why we're talking about the dimming of LEDs. It's the energy side, but then there's also the code side that it affects. So if we take a look at the LED types, just breaking it down into simple terms, LED bulb, okay, with an LED bulb, one of the thing there is similar to a CFL. Okay, CFL self-ballasted, right? Your snow cone, you had the snow cone, and then you had the big section at the bottom. That big section was the integral fluorescent ballast. Same thing if you're doing a screw-in replacement, you have the integral LED driver into the screw-in. Talking about the heat, so if you look down at the bottom, that's where the heat sink is on the bottom where you screw into the Edison socket, okay? And so this is designed to replace the standard incandescent into the Edison sockets, and you have the integral drivers. Now, an LED integrated fixture, okay, this is where you're going to have separate units. So you have the LED lamp module or the LED engine, and then you have the LED driver that is a separate piece. Okay, and then that all goes into the luminaire, goes into the fixture. So you have a separate driver from the light engine, and then you'll have a control that would be upstream of either of those options. And then we'll also talk about some things that are going on where you actually have the controls closer to the fixture in commercial applications. Okay, so usually the driver is externally mounted depending on the load requirement. So you may have on a commercial fixture, you'll have the driver in the fixture for smaller loads, but then for larger loads, you may have the driver that's external to the fixture for the heat issues and things like that, and just getting that amount of wattage to the fixture. Okay, so there's a lot to take into consideration when you are looking at the LEDs. Okay, we've talked about controls compatibility. So the compatibility varies from fixture to fixture. Okay, some things that end up happening is if you get a fixture from a manufacturer 1 month, 3 months later, they may have changed their LED driver supplier. Okay, and then changing that LED driver supplier can change some of the things that Tanya was talking about as far as color and things of that nature. Okay, not all LEDs are dimmable, especially looking at residential and screw-in and those types of things that you get at the big box store. There is an upcharge for a dimmable screw-in LED. The majority of your commercial troffer and those type of replacements, a full fixture, those are dimmable. I'm not even sure if you could get just a switching 2x2 LED fixture anymore. Now, TLEDs were brought up earlier. We're going to address that. TLEDs switching is still prevalent there. Okay? Color consistency. We already talked about that as well with color shift. Depending on over time, you'll get color shift, and then from manufacturer to manufacturer. I'm not addressing it specifically here, but since we do have extra time at the end, if there is any interest in sort of the color tuning circadian rhythm type of conversation, we can have that afterwards in our open section area. Just wanted to put that out there because I will forget. That's what happens with me. And then the last of it, thermal management. We also talked about that as well because yes, LEDs generate less heat than a fluorescent. Why? Any engineers in the room? I squared R, right? If you have less watts, more efficacy, less watts, I squared R, less current, I squared R is your heat, less heat. So by definition, they put out less heat, but you still have to dissipate that heat in some way. And if you think about the same problem you had with CFLs, when CFLs came out, they're the solution to everything. They're going to last forever, okay? That lamp hour was based on you screwing it into a lamp with the with the screwing it down into a lamp where the heat goes up into the room and dissipates great. Okay? What do we have up here? Cans. So what are you doing there? The exact opposite. You're putting the temperature sensitive device at the top where the heat rises and it's basically an oven. So that's why the CFLs kind of got a bit of a bad name when they came out to market because they got nowhere close to the life that they were talking about on the screw-in side. Same thing on the LEDs. If you're putting it into the lamp on your nightstand, great, no problem. It's going to be dissipating heat till it'll last forever. Okay, going into a can, you're going to have that same issue where you are going to have some temperature thermal management type of issues. Okay. And so we've also talked about some of these in the previous presentation. Flicker, those types of things. I'll sort of talk about how the technology addresses that. Multiple of control types. We're getting to the point where we're getting more and more standards for the industry as far as inrush and things of that nature. And then on the driver-related challenges on the more commercial type of applications, you know, the integral driver to the fixture versus the separate remote driver. LEDs are reactive to line noise, so you do have that issue that can cause some problems. Stability of the DC output from the driver itself is important as to how it's going to affect the LED light engine. And then this is the other key that we touched on at the end. The driver must be designed for the same lifetime as the LED. When they first came out, LEDs, 100,000 hours, great. You know what they're talking about? They were talking about the light engine. They weren't talking about the driver. You got to read the little fine print and the asterisk at the bottom. So you would have an LED with 100,000 hours, which the light engine, the driver had a 40,000 hour life. And when was the last time anyone went up and changed the driver in an LED? They're not designed for that, number one. Number two, code didn't allow it. UL didn't allow it. It's only recently that there are temperature rated drivers similar to fluorescent ballasts, right? Fluorescent ballasts, you can replace the same wattage with the same wattage because UL had testing that said a 32 watt ballast, you know, you can only put out X amount of heat. So if you replace it with that same ballast that meets UL, you're fine, you're not going to burn the building down, right? They didn't have that with LEDs. There is a new type, a Class P type of driver that is now just coming out. That standard has just come out saying that, okay, if you replace a Class P driver with a Class P driver, you're not in violation of UL. So initially things come out, 100,000 hours, you really only have 40,000 hours, and by the way, you can't replace this 40,000 hour piece, so you have to replace your whole fixture, right? I'm in sales, I get why you do it, but not in the best interest, you know, not truth in advertising, let's say. Okay, so that is another piece where you have to match those things up. The driver life is usually the lower life item in the fixture. Okay. Nope, that's not what I wanted to do. Okay, so now we're going to sort of move into the control strategies, and we're going to address the wall box first. So this is going to be your residential applications. This is also going to be your commercial applications where you have potentially you have a switch or a wall box dimmer on the wall, and you're looking at doing an LED replacement. Okay, so if we take a look at, we've talked about incandescent, so 1800s, traditional lighting, a switch and an incandescent. You know, funny thing, we were talking about the efficacy of the incandescent. Does anybody know what technology the incandescent light bulb is the closest to? It's in your kitchen. It's the oven. Basically, all you're doing is you're heating up metal hot enough so that it gives off light. So think about lighting your kitchen with your oven, right? Not very efficient, okay? But it's cheap. You know, it's 79 cents, 59 cents, so that's why it was prevalent for so long, okay? 1960s is when we introduced rotary dimming. The great thing about it is all you got to do is control current like we've talked about, so very simple, very straightforward. You bring the current down, you don't heat the filament up as much, you don't get as much light out, and you get that great lamp extension as well because of that I²R that we've talked about. Today, you know, and then there was a pretty rapid change from CFL to LED. You know, we track these things, and we were looking at incandescent controlled everything 8 years ago. Right? Then CFLs came out and we saw, you know, CFLs growing, LEDs kind of small, and then LEDs, you know, 15 years later replacing the CFL. It happened like that. I mean, LEDs just crushed CFLs. Cost came down so much faster than anybody thought. So now LED is now the prevalent form of energy efficient lighting that you're going to get. And it does add some challenges that we're going to talk about. So some of this we've talked about, introducing voltage into the incoming power line. Okay, so the LED driver itself will induce voltage into the line, which dimmers are sensitive to voltage, all electronics are sensitive to voltage. We talked about the LEDs have high inrush current. Okay, we have seen things on the commercial side where you're talking about 10x, 20x your current for your inrush. We've seen things that say for a 16 amp circuit you can only put one fixture. Okay? Some of that is now being addressed by the NEMA standards, but that's one of the things where inrush current can be significant because you have a lot of electronics in that driver, and depending on how that driver is built, all those electronics have to get charged up before it puts anything out. And so you can get a huge instantaneous inrush, and that can cause significant problems. So that's one of the things to check when you're looking at specifying things. And then we talked about this a little bit. Different LED bulbs have different dimming ranges. You know, I've seen 1%, I've seen 10, I've seen 20, I've seen 50%, meaning that you can only go down to 50%. Perceived light level, that means your dimming range is 100 to 80% dimming, perceived. I don't think anybody in your facility would be very happy with that type of, you know, performance. Okay, so that's the other thing to look at. And then one of the things that causes pop-on, which means since if it only dims down to 20%, well, that means it doesn't start at 5, right? That means that the old rotary model, you turn it, nothing happens, and then it pops on at 20%, which is closer to 50% perceived light output. Okay, and then flicker, we've talked about that quite a bit. So kind of taking a look at sort of the dimming technology. Okay, so for the LED dimming, what you do is you have instead of just the traditional triac, which is the device that's turning on and off to generate that PWM waveform, or the not the PWM, the phase cut. Sorry, you're going to have the triac, microcontroller, and a MOSFET. So just taking a look at the two technologies, right? On the right, your traditional incandescent dimmer. Versus on the left is what's a CFL LED specific dimmer. So you've seen you replaced a lot of metal, right, with electronics. And that is in order to handle the voltage, a lot of the voltage piece of it, some of the irregularities that come from the driver, especially those self-ballasted LED drivers, back into the dimmer, into the wall box. Okay? So it really comes into play to say, oh, hey, I've got a dimmer that I have on the wall doing my incandescents in my conference room. I'm good to go. I'll just take those incandescents out and I'll just put in LEDs. And then you wonder why you get flicker and why you get overheating in the dimmer, why you potentially pop circuits and things like that. These are the things this is what this affects. Okay? And then one of the other things to sort of address the adding load to a circuit, one of the other things that technology does means that now you can use that dimmer with only 1 watt of load. Because that was one of the problems earlier with the traditional dimmers, that you would put the LEDs on, the dimmer needed 60 watts of load in order to function, in order for the electronics to function. So yeah, you do an energy project where you put in a bunch of LEDs and then you add an incandescent dimmer just to load so the dimmer would work. Okay, so that's where the technology has addressed that. So that's also getting a dimmer that's specifically designed for LED should resolve those issues. But then if you are looking at something, just check. Does it say a minimum load requirement? Does it say a certain minimum dimmer range, that type of things? And then adjusting the pop-on. And that dead travel at the bottom to adjust for the various levels that the LED, the dimming range of the driver. Very simple. You put a dial on the dimmer and you say, okay, I'm going to run the dial up until the light comes on. That's my new low end. So now I turn the dimmer on. Instead of starting at 1%, it starts at 5, 10, 20, whatever the number that is. So that way you don't get that travel at the bottom where somebody's pushing a button or turning a knob, nothing happens. Then they get mad, then they call facilities, then you have to take everything out, and it's a big problem, right? Okay. So if we take a look at that, any questions sort of on the screw-in, control of the screw-in solution? Okay. So we'll go ahead and move into the commercial fixture control, which I think there's probably, I'm assuming, a little bit more interest on sort of the linears and what's going on there. So if you take a look at it kind of breaks down on what solution that you apply where. There isn't a one size fits all. So I kind of break it down between new construction or retrofit as to what solution you may want to go to. So in those, and even on the retrofit side, do you want to do a new fixture, or are you pulling the whole fixture out? Like in here, maybe you don't like that lens and everything else, so you want a whole new fixture, or maybe you want to use a retrofit kit where you're going to keep that existing frame and put in a retrofit kit. Okay? Like I mentioned earlier, all LEDs are dimmable as standard, and then we also have the tubular LEDs where the thought is it's more like a lamp replacement and you want to use the existing technology, easy to retrofit. The majority of the TLEDs though are switching, which means now you're not getting the additional savings, and you're also not meeting the code requirements as well. Okay? So why the drivers are so important? The driver is what determines the best dimming performance. So the driver itself is designed to either have 1% output, 5% output, 10% output, maybe 20, all right? And I'll give you a guess, which one's more expensive, 1% or 20? 1%, right, is more expensive. And so that's where you look at, all right, conference rooms, teleconferencing, maybe I need 1%, okay? Lecture halls, I need 1%. Corridors, hey, 5% is fine, 10% is fine, right? So why add the cost of 1% everywhere if you don't need it in all the spaces? Unless it's a stocking issue where you want to just stock a single product at your facility, okay? And then we've talked about the dimming curve already, and then the smoothness as well. So there is the point where you do have to make sure that the driver is matched up and coordinated with the LED engine like we talked about. And selecting the right driver will eliminate a lot of what we're talking about on the flicker, all those types of things, dimming performance, that type of stuff. Okay, so tubular LEDs. How many people have used TLEDs? Okay, how many of them are dimmed? Very right. So some TLEDs there are some TLEDs that are available as dimmed. Really quickly, the different types. Type A, utilize the existing fluorescent ballast. The one thing that I'll say there, do you go in, if you've got a 1995 computer, do you go in and change the monitor and leave the computer? No. So why put a new, a 2017 technology device on a 15-year-old ballast that has a 10-year life, right? And you're going to have to go back and replace those same things with the tombstones. So if you are going to do the TLEDs that utilize the fluorescent ballast, it makes sense to replace the ballast and the tombstones at the same time while you're up in the fixture, okay? You have the direct wire to line voltage where you bypass the existing ballast and you just do line voltage to the TLEDs. There are some benefits there from a cost installation side, but you do have that inherent risk that you now have line voltage to the lamp. Depending on who's doing your lamp replacements, maybe it's the maintenance staff, maybe it's the custodial staff, maybe it's the annoyed person in the office whose lamp is out and decides they want to replace their own ballast. They're now accessing line voltage, so there is an inherent safety risk there. Type C is that it's supplied by an LED driver. Okay, so that is, so now you're taking care of that issue of, is it compatible dimming and everything else, you do that all at once. The one thing that I will say, we do a lot of performance contracting work, those types of things. If you don't put controls in when you change your fixture, you'll never put controls in because your ROI just won't work because your connected load is already lower. Your labor cost is double because you have to go back up and down on the ladders. You have to do that twice. So your ROI just doesn't work if you don't do controls at the same time that you do your fixtures, whatever technology you use. Okay? So taking a look at the implementation side, okay? How do we apply the technology for new constructions versus retrofit, talking about 0 to 10 volt zoning, because the standard LED driver is 0 to 10 volt standard as an output. So when do we want to use that? When do we want to use what's called digitally addressable, a digital addressable ballast or driver, or individual fixture control? So essentially what the bottom two lead you into a digitally addressable luminaire versus a 0 to 10 volt zoning type of setup, okay? So where does it make sense? So first off, 0 to 10 volt control, fairly straightforward. Probably everybody's familiar, been using it with fluorescent all the time. You have a hot and a neutral that goes to the device, whether it's a dimmer or whether it's a control module. It supplies power to the fixture, and then it also supplies a 0 to 10 volt control signal. So it's control as well as a switch, okay? Then if you look at digital control, you're not supplying power through the control, through that device. The controller is just a digital link that's providing communication that is telling the driver in the fixture what level to go to. And power, you can see, is supplied separately, and that would go through a traditional lighting panel is where the power would come from. The difference there is then each fixture is digital, and it is addressed to say, okay, in response to this photo sensor, I'm going to go to this light level. In response to this button press, I'm going to go to this light level. All of that is stored at the fixture as opposed to be stored at the controller. Okay, if that makes sense. And so what it does is it allows you to easily layer control strategies on top of each other, and you also don't have, you can rezone it through software as opposed to through electrical wiring. So if we take a look at doing a design with digital versus 0 to 10. So this is sort of a standard classroom type of setup. You have a whiteboard on the left, you got a window at the top, and so how would you zone that as a lighting design or in a facility? How would you want that room to operate? Okay, what would be the sequence of operations? Okay, there's a lot there if I look at it from a zoning standpoint. So what I have is, I want to have a zone for the whiteboard. Ideally in this room, I could have the lights dimmed over that screen as opposed to the same light level as the rest of the room, okay? But I do want to have control, common control over the classroom itself. So that way I can have in front of the whiteboard maybe at 5% and then 70% so people can take notes but don't fall asleep, okay? Now we also have a window there, so based on our previous review of ASHRAE, currently we would have to have 2 daylight harvesting zones there as well. Okay, and then the final thing, it's a little bit hard to see, but the whole room is in green, and that's for occupancy. So that way all of the lights go off in response to the room being vacant. Okay, so if we take a look at personal control zone, daylight zones, how do we wire that up? So we're looking at 6 zones there. So if we take a look at how we're going to do that with a 0 to 10 volt or even switching to meet those requirements, okay, we're going to have 6 boxes with a lot of power wiring to do that. Okay? Now if we take a look at if you do it digitally, you're going to have 1 digital loop for the whole room, and then through software everything is going to be changed that way. Okay, everything would be addressed that way. Right, so from an install side, it makes it significantly easier. Okay, now if we so you got 1 digital box that's going to be controlling that. Power wiring it can be 120, 277, doesn't matter what the lights are powered by. Everything's done digitally. Okay, so you only need 1 box. Now, what I'll say, the other piece of it, so this is talking about an intelligent driver. Okay, the other thing that you can do is there's a lot of manufacturers now that have an individual fixture control, luminaire level control. You hear that through DLC. Okay, so now what you're doing is you're taking a standard fixture, LED fixture with 0 to 10, and you put a box in it that it provides the 0 to 10 volt signal and then also provides the switching as well. Okay, so now what you're doing is very easy from a retrofit standpoint to get your digital individual fixture control where each fixture operates independently. Okay, so this makes a lot more sense from a retrofit standpoint. Okay, you either have a box or you also have some smaller, lower profile type of units that fit into that setup. So if we take a look at, so you could say by what I'm presenting and by who I work for, hey, digital is the best way to go. You should do digital all the time. Individual fixture control, I'll tell you, you won't go wrong with individual fixture control. Okay, but just like I was talking about a 1% driver versus a 10% driver, what's more expensive from a material standpoint? A dumb 0 to 10 volt driver or an intelligent driver? Intelligent driver is more expensive. What's more expensive? A 0 to 10 volt driver or a 0 to 10 volt driver and a module? Well, unless the module is, we pay you to take the module, that's going to be more expensive, right? So you balance out your material cost versus your installation cost versus your functional cost, your sequence of operations. If you look at that classroom, how much does it cost you to wire up 6 different power zones and 6 different control zones? Quite a bit, right? So digital makes all the sense in the world. So now I'm looking at a corridor. All right, for new codes for corridors, maybe you have unoccupied to off. Maybe you have unoccupied to a low level so that you meet your minimum foot candles. You may have occupied to 70% light level. You might have occupied to 70% light level during the day, 40% light level at night after hours. Enough light for security to go around, but not as high of a level. So digital would work great, right? Digital would accomplish that. Is that the best way to go? You still have to run control wire. I work for Lutron and I sell digital drivers, so yes, digital is the best way to go. Or your install cost is the same, so for this one, why not just go with 0 to 10 volt, right? So now you've got one zone, it's controlled the same. You can use that technology to have all the fixtures at 10%, 50%, 75%, right? And so that's why I say there isn't a one size fits all that is going to change it. Now, new construction, I do a 0 to 10 volt 100% of the time. Retrofit, maybe it's going to be easier for me to use a wireless module that has RF control that just goes to each fixture, so that way I'm never going up and I'm not running any control wire. Or, hey, if there's asbestos, well, now what I can do is leave the fixture in place, replace the guts, put a wireless control, never go up into the ceiling, and now I'm meeting code, have control, and don't have to worry about abatement.
Is the vibe that you pointed out, is that wireless?
It is, yes. And there's any number of manufacturers that would have a module that goes at the fixture that would then communicate wirelessly to occupancy sensors, daylight sensors, and then potentially either just be standalone like that, or go upstream into some type of hub type of network that could go into a building management system as well. Okay, so you can get a wireless or a wired solution from multiple manufacturers for all of your fixtures, depending on what the control requirements are, what the sequence of operation is. Okay.